Welcome to this video on safety in the high school chemistry lab. This is Mr. Suker. And as you watch this video, along with the other videos that we will do throughout the year, you're going to want to take notes, as the video is sort of a skeleton outline of our topic. And I will fill in some other details and give some examples along the way. So you have a few options of how to take notes. One, you can just watch the video and then record notes in your journals. You could print out a copy of the slides if you'd like. The slides are posted in the class shared Google Drive. Or if you really want to get fancy, you could use the PDF if you happen to have one of the handwriting apps for a touchscreen device. You could actually take and make annotations on one of those using something like the Kami website, but that's only if you have the a touchscreen device and then a link to the kmiapp.com website. So whichever way you choose to take notes, have that available at any point during the video. You can pause, go back, and watch it again, and this will remain available on the YouTube channel for you to watch at any time that you would like. So let's get started with our summary and quiz prep for laboratory safety. First and foremost, safety is everyone's responsibility. Here we see a whole bunch of different ways to communicate hazards. I'm not really sure what the one on the upper right is looking at. I guess that looks like, an accident that happened in line at Chipotle. I don't know what. But there are all sorts of different safety hazards. There are physical hazards, there are biological hazards, there are fire hazards. But when it comes down to safety, it's everybody's responsibility. It's yours, it's mine, it's your family's, it's even Mr. Guerra's. If we're working in the chemistry lab and Mr. Guerra comes walking in, he does that from time to time. He just pokes his head in because he's curious to see what's going on. We need to make sure he is safe in lab. And I always find it kind of funny when he does show up and the students are like, Mr. Guerra, you can't be in here without your goggles on and an apron and gloves and a hard hat and whatever else we can put on them at that time. But really, guests, faculty, students, everybody has to practice safe practices at all time. So the key steps to safety. We really want to mitigate risk, and mitigate is a word that has been thrown around a lot lately. All of the things that we are doing at BTA right now related to COVID are about mitigating exposure, meaning we can't 100% guarantee that there's not going to be any exposure to COVID or the flu or the cold or cooties at BTA, but we want to try and reduce that risk as much as is possible or practical or whatever standard we happen to set for reducing the risk. So the word mitigate means to reduce the effects of. So we want to reduce the effects of any potential risks that we may face in the chemistry lab. Part of that then is identifying and knowing what the hazards are. When we're working with fire, we need to recognize that fire is a hazard. It could catch our clothes on fire. It could catch our hair on fire. One of the steps in the lab is if you have long hair, you want to make sure that it's tied back. So if you happen to lean forward, it's not going to fall into the flame and catch on fire. My suggestion, if you do have long hair, is just to keep an extra hair tie in your backpack. And that way you always have one if you happen to need one if we move into the lab. We can identify potential trip hazards. In our lab, the stools do pose a trip hazard. I find that, generally we do pretty well, but if, you guys happen to be an exceptionally clumsy class, maybe we'll have to pull the stools out, because I do know some chemistry teachers really believe that you should be standing at all times in the lab because that removes any potential for tripping over the stools. Chemical hazards, fire hazards, even spilling water on the floor poses a potential hazard, and we need to be aware of all of those when working in the lab. Maintaining a clean, neat workspace is the number one step to safety. The most common cause of laboratory accidents, according to the Occupational Safety and Health Administration, OSHA, which is the federal government agency in charge of safety in businesses, schools, and workplaces. The number one cause of laboratory accidents, according to OSHA, is slips, trips, and falls. And so certainly keeping things neat, keeping them organized is a good way to help prevent major types of accidents. You also want to practice proper disposal and cleanup. Hazards can be created if you don't throw things away or dispose of them properly, so you have to be safe during cleanup. You need to store things properly, you need to put them away in the right way. All of these are key steps to operating safely. And because we're just looking to mitigate risk and not eliminate risk, know how to respond in case of an accident. We never want an accident to happen, but we also have to be prepared just in case it does. We should know that in our lab, we have the wall phones, and really this goes for any place in the building. If you have a friend that gets hurt or something gets spilled, you can pick up any school phone, press the top button on the phone, which is labeled office chain, and that will automatically ring all of kind of I don't want to say the most important people, but the people on our emergency response team that will know how to put things into action that will help take care of your emergency. So if you do call the office chain because of a problem, make sure that you tell them 3 things: who you are, where you are, and what the problem is. So that way they know how to respond and they can follow up with you if they're having trouble figuring out exactly what happened. So who you are, where you are, and what the problem is. And tell them slowly and calmly. I know that's tough to do in an excited situation, but certainly taking a deep breath and being able to calmly work through a problem is a good skill of any first responder, and it's something that's good to practice in case of any sort of emergency. As far as chemical hazards go, what's specific to us in the chemistry lab, one thing that's very important in our chemicals is that they're properly labeled. If you ever come into the chemistry lab and find that something is sitting on the table that is not labeled, 1, that's bad, and 2, always treat it as hazardous until you get information to the contrary, until you find out information otherwise. It's the better safe than sorry principle of assuming something's dangerous until it's shown to be safe. Better practice, though, is to make sure everything's always labeled. And chemical labels will include things like name, the GHS, the Globally Harmonized System, and the NFPA placards. Usually you only see the NFPA placards for something that was produced in the United States. You'll see information about appearance and storage. Certainly you'd like to know if it's supposed to be a white crystalline solid and you open the jar and look in and it's purple. That may mean either something has gone wrong with the substance or it's labeled improperly. And then how should it be stored? And then a real quick summary of hazard and response. You're not going to fit everything on the label of a bottle. If you really want to know everything, you go to the SDS, the safety data sheet. These have to be kept on site for everything that is identified as a chemical. This is not true for your house, but every chemical in your house, be it dishwashing detergent or Windex or whatever it happens to be, it should have a label. And all of those products, if used in a school or business environment, also have to have an SDS with it. So while you might not have to have an SDS for hand sanitizer at home, we do have SDSs for our hand sanitizers here at BTA. So the SDS gives you the full information. You've worked with them a little bit. How hot does it have to get before it lights on fire? What does it, how much does it dissolve in water? Those are multiple pages long. They're not to be memorized. And certainly the chemical label on the bottle needs to give you at least the information to start with. And if you need to know more, then you can pull out the SDS and go from there. Also on the SDS's, required information is a manufacturer contact. So if there's some issue with the product or questions about it, you'll know who to call in case of response to some sort of emergency involving it. So this is an example of a bottle label from a Flynn Scientific bottle. Flynn is a company that we get a lot of our chemicals from. And you'll see, if you look around, you'll see the name of this particular substance, sodium hydroxide. You'll see its formula, NaOH, that it's soluble in water and alcohol, that you need to keep it in a tightly closed bottle. Disposal, it says number 10. They have this little handout that gives all sorts of disposal methods of how to get rid of things. Also, the inorganic 4 coding is something that they use to say that anything that's labeled inorganic 4 can be stored together, because you don't want to store something like this happens to be a base, and you wouldn't want to store it on the same shelf as acids, because if there is a leak out of the container, then that would be bad. So the acids are labeled with a different code, and you never store items with the same storage code at the same place on the same shelf. You keep them separated. And if you ever poke your head into our chemical storeroom, you'll see that the shelves are labeled with these different code numbers. You also see the immediate threats: causes severe skin burns and eye damage, do not breathe dust, and then some first aid of what to do if you are exposed to it on there. And you'll see, it says if swallowed, if on skin, if inhaled. There are different responses depending on how you're exposed to a chemical. So not only what you're exposed to, but how you came into contact with it. And we'll talk about that a little bit more later on. So what we're talking about there is route of exposure. So route of exposure is the method by which your body comes into contact with the chemical. And there are 3 terms, specific terms, that go with route of exposure: inhalation, breathing it in; ingesting, eating it; or contact. And these are the specific terms. Putting it in your mouth is not a route of exposure. Ingestion is the specific term for route of exposure. These are commonly used throughout the chemical safety industry. So something that may be dangerous by ingestion may not be very hazardous if you touch it. Something that is extremely dangerous to breathe in may not be so bad if you eat it. Water would be an example of that. You don't want to breathe in water, but certainly you can consume water, and it's good for you. So different chemicals affect us in different ways, and so the exact hazard posed by a chemical can depend on how you're exposed to it. The hazard from a chemical can also depend on dosage. Dosage is how much of it that you consume. There are many things in our lives that we consume in small amounts that are perfectly good, but in large amounts they could be harmful to us. And sugar is a great example of that. We need sugars in our diet, but if you have too much sugar, that can be hazardous to you. There are certain chemicals like those in chocolate, that the certain chemicals in chocolate that, trigger the response of, ooh, I like chocolate. Those chemicals to our body aren't overly hazardous, but to, say, a dog that is much smaller, those particular chemicals can be toxic. So, it has to do with body mass. I know one of the very first things they do when a child is born is they weigh them, because if they do have to give any medications to, an infant, medicines are always dosed based on body weight. So if you're in the hospital with a newborn child and that child may need some medicine, you have to know right away the dosage of medicine to body weight ratio that you're going to need to give. The other thing is time of the exposure. You may be exposed to something over a short time, or you may be exposed to it over a long period of time. So a short-term exposure is called acute, so something all at once, whereas a long-term exposure is called chronic. And for certain substances, a small long-term exposure may be as dangerous as a large short-term exposure. So something that, gasoline, if you get exposed to a lot of gasoline very quickly, that's going to be obviously very hazardous. But even continuously breathing small amounts of gasoline vapor, like might be in an auto repair shop or something like that, over a long period of time, could also pose a particular hazard. So how harmful a chemical is to you is really dependent on not only the nature of the chemical, but also the way in which you come into contact route, dosage, and time. This is a label from a common antibiotic, Augmentin, and you can see lots of information here about it. This is one where the pharmacy actually has to produce a liquid medicine. If you've ever had an antibiotic when you were a kid that you had to take with a spoon, Augmentin is a common one to give. But, they talk about here that, in the dosage, each 5 milliliter dosage contains 125 milligrams of the Augmentin medication. And so as a doctor, you'd have reference tables to where you would look at your patient and you'd say, okay, here's a child that has a body weight of 60 pounds. And so they have an ear infection and I need to give them medication. What dosage of medication should I give this child at this particular weight? That's another reason why, not only, when you're a kid, when you go into the doctor, not only do they measure your body weight to just look at growth patterns, but also if you're going to need a medicine, they're going to need to give the dosage based on your particular body characteristics at the time. Obviously, I probably need a greater dosage of pretty much everything than any of you do, but that's a topic for another day. GHS pictograms. Know these. These are considered to be a government standard communicating hazards, and we did a little bit of a discussion in class about which is better, GHS or NFPA, but this is the legal standard labeling system right now. So you have explosives, flammables, oxidizers, and that's also can be spelled with a Z. But flammables mean it will burn. Oxidizer means it produces oxygen that would make a fire worse. So you see it looks like looks very similar to the flammable symbol, but really that is a letter O in the middle. And it just means that if there is a fire, in the presence of this substance, the fire will be worse. And that's what we believe happened in the Beirut explosion. Ammonium nitrate itself does not burn, but it is an oxidizer. So there was reportedly a fire in a building near the ammonium nitrate, and the ammonium nitrate became hot. It began releasing oxygen, and then that caused kind of a chain reaction. Things spiraled out of control. And the next thing you know, there was this massive explosion. So, the different hazards here, corrosive, the most gruesome of all of them with the picture of the liquid dissolving the thumb on the hand. Acids tend to be corrosives. Bases, the chemical opposite of acids, are also corrosive. If you go out to your family's car and you look on the battery, you may very well see the corrosive symbol on the car battery because car batteries are filled with sulfuric acid. It's part of how they work. We'll look at that later in the year, but that acid is corrosive. You have gases under pressure, which is supposed to look like like a CO2 cartridge from a paintball gun or something like that. The one we talked about in class, the acute toxicity, so immediately toxic, versus the exclamation point, which are irritants and other kind of health hazards that aren't as immediate. There are other hazards, the Iron Man one there, that can be genetic mutation hazards or other biological hazards, and then the dead floating goldfish there of the environmental hazards. So that's the collection of GHS pictograms. Take some time to review those. And then as far as that goes, once we know the hazards, once we've identified those, how can we mitigate risk? In our lab, obviously following directions is the first step. Ask for clarification if you're not sure of the directions. And honestly, sometimes I roll my eyes when it says, put water in the beaker. And you say, hey, should we put water in the beaker? I'm going to be like, yes. But in spite of all of that, I do want you to ask. I encourage you to ask. If it makes you feel better, ask. If you have any doubt whatsoever, ask for clarification. Do not experiment, and I put that in quotes. We do laboratory experiments, but don't say, hey, I wonder what happened if I mix these two things, if you don't kind of already know what will happen when you mix those two things. Don't do unauthorized playing around of things. Don't, put things together if you don't have a good idea first of what's going to happen and that you're prepared and have the right equipment and the right procedures and all of that to do that. Don't just double amounts for the fun of it. Some things are very manageable in small amounts, but if you put too much into the container, it can go out of control. So don't do unauthorized experiments. Follow safe practices, so just do things properly. When you unplug something, grab it by the plug and unplug it that way. Don't yank it on the cord. There's all sorts of practices that are kind of standard procedures for doing things. And wear proper PPE as a second line of defense. PPE stands for personal protective equipment. Your COVID masks are PPE. Your clothes are actually PPE. But really, we're talking about gloves, goggles, lab coats, aprons. Construction workers often use shoes or boots that have a steel cap on the toe so that if you drop something on your foot, it's not going to smash your toes, or a steel plate in the sole so that if you happen to step on a nail, it's not going to stab you in the foot. All of those things are PPE. But PPE is a second line of defense. What would be a better line of defense for our construction worker? Make sure you don't have nails laying around. So just because you're wearing gloves doesn't mean you can just stick your hands into a vat of chemical. The gloves are there in case you accidentally get some on your hands. Goggles are there to prevent in case you accidentally splash something. But don't intentionally be splashing things on your face just because you have goggles on. PPE is the second line of defense to following safe practices in the first place. And respond immediately and appropriately. If you spill something, clean it up right away. If you've broken something, get my attention. Say something right away. Don't let it sit around. Don't let it go till later. We were out at lunch today. It was lunch or break, and there was a younger student, I believe a middle schooler, who left a Doritos wrapper or Cheetos wrapper laying on the ground. And somebody said, hey, so-and-so, pick that up. And they turned and ran. Okay, don't be that person. If there's something broken, something spilled, whatever, take responsibility, get it taken care of, because if you don't, then it could be the next person that has a problem. If you spill water on the floor and you don't clean it up, it'll be the next person that comes along that slips on it, and we don't want that to happen. So don't be afraid. We don't charge for broken things in lab, and I may grumble and I may roll my eyes, but I'm not going to get mad about these things. We just need to make sure that we get things cleaned up, and we'll talk about, hey, how can we prevent this from happening next time? You look at Tuka-Rask, there's a whole lot of protective equipment on there. Shin pads, the leg pads, the blocker, the shoulder pads, everything. He's got this very expensive custom painted helmet on, but it's not Tuka-Rask's goal to get hit in the face with a puck. The goal is to block the puck, to use your blocker, to use your stick, to kick it away, to catch it in your glove. But intentionally stopping the puck with your face, I don't think is in hockey goalie school something they teach you. So the mask is there as a second line of defense. He wants to catch the puck or steer the puck away first, but just in case he doesn't get it, then the mask is going to be there to protect his face from the flying puck. Do you realize that there was a time in hockey when goalies did not wear masks? I don't understand that. It was a long time ago, thankfully. Responding to accidents. Clean up spills immediately. We have an injury code word in the lab. We only use this in a time when somebody is hurt. So if somebody gets cut or somebody spills something on them and we need to address a problem with a person, the code word said strongly and loudly is emergency. Breaking a beaker is not an emergency. Breaking a beaker is, hey, Mr. Suker, I broke a beaker. But if the word emergency is spoken in our lab, everybody will stop what they're doing. They will locate the source of the emergency, and they will judge how they personally need to react. But that word is very important to know as our injury code word in the lab. If there's an unexpected, uncontrolled laboratory fire, remember that your response should be evacuate first, notify second, meaning pull the fire alarm on your way out. In the school, there are fire alarm pulls near every door, every exit door. So if you're leaving the building because there was a fire in the lab, make sure somebody pulls the alarm on their way out. And then even at home, consider fighting the fire last. So if you happen to have a kitchen fire, get everybody out of the house or get everybody out of the apartment, get toward the door. You should have a fire extinguisher in your kitchen or in your garage somewhere near the door. And then you can decide, do I grab the fire extinguisher and try to put it out? Because worst case, if you try to put it out and it doesn't go out, you can escape easily and everybody else is already out, and that's the safest route to go. Remember that lives are more important than property, so the thought of saving property is the last thing that you should think about in case of a fire. And in bold, very important statement, we must accept that an accident is always a possibility, but when one happens, we must work to prevent it from happening again. The saying goes that all accidents are preventable. We try to prevent all accidents. They're all preventable. But it's always a possibility. We have to be prepared to respond, and we have to be prepared afterwards to reflect on what happened and figure out how we could prevent that same accident from happening again. So, as the saying goes in any language, no matter whether you're taking French or Spanish, safety first, pay attention, report accidents. This is something that no matter where you are, where you work, where you do things, we want to be safe. And so think safety first as we work in the lab, and feel free to go back and review this video at any time as you prep for the safety quiz. And also, if something happens, I may say, hey, let's go watch the safety video again, but it'll be there. Thank you for watching. Thank you for taking notes, and I will see you in class.